Hello everyone, I'm Henry and here I'm going to talk about the big project for High School Math 2, and the title of this project is Henry's Parabola Rainbow. So first in here I'm going to find the quadratic function which matches the picture that I chose, which is the rainbow. I'm going to use the way that Mr. Freddy teach me to find out the parabola. Just using 2x intercept and the height of the thing that we want to find out. Using these informations, we can find out the quadratic formula of the pictures that match it perfectly. So here's some informations, and here's an introduction. So in this big project, I have to find the quadratic equation for the picture that I have chosen, which is the rainbow and the fountain. And while finding this equation, I will have to solve many things, and I must soon be knowing the basic knowledge of parabolas and quadratic equations, like the form of it, how to change the forms, for example, like factoring the equation and all those things. So this thing I'm going to show is how you're going to find a parabola which fits the thing that we want to find by only using 2x intercept and the height of the parabola. I choose rainbow as my parabola that I'm going to use on this big project because if you are interested in animation or other things about animations, and you want to create a rainbow in those animation things, you must have the equation for making the rainbow, right? And here is the project which makes these things looks easier for those people who doesn't know about this equation. Okay, but there's a problem. The problem is this equation isn't the same for all the rainbows, and it depends on which rainbows and which pictures are you trying to find. So after I teach you this, you can go find by yourself. Okay. So the method. In phase 1, we have the exercise questions, which is the water fountain arc A and B. So the question is asking, arc A has parabola jet height 2.5 meter and the parabola horizontal jet spray distance is 4.5 meter. In this case, we only know the height and the water fountain 2.5 meter high, and the distance of the fountain, which is from 0 to 4.5. But it's enough for us to find out the original equation. So let's start the formula with y equals to ax squared plus bx plus c. As you can see, so this is the original equation that we must have at the end, but we can't just put our information in unless we break it down or simplify the formula to be like this. As you see, y equals to a bracket x minus m bracket and bracket x minus n bracket. So this is what we call factoring, and we can able to put our 2x intercept into the formula. We know our m equals to 0 because and n equals to 4.5 because in the question they told us the jet spray's distance is 4.5 meters. So it's from 0 and 4.5. It's like what you call the common sense. So we put this information into the formula that we just have. So it will be a bracket x minus 0 and bracket x minus 4.5. And now we must to find the vertex for the parabola. As we know, the y of the vertex is 2.5 meters. So the jet can shoot high at 2.5 meter, and we need the x of the intercept to find it is used. So in here it basically means we must find the vertex. Yeah, but we already have the y, but we have the y coordinate, but we don't have the x coordinate, so we must find it. So how we're gonna find it is using this formula. So it'll be x2 minus x1 divided by 2. So in here it's 4.5 minus 0 and divided by 2, and we will get 2.25. And this is the x for the vertex. So it's the x coordinate. The coordinate will be 2.25, and this is the x, and 2.5. This is the y coordinate, and we fill it into a formula as 2.5 equals to a and bracket 2.25 minus 0 and bracket 2.25 minus 4.5, and we can solve for, and then the a is missing right now, so we can solve for a to complete the function. After simplify the equation, it will be like this for the following steps. So here's the steps that I just did. Yeah, so it'll be 2.5 equals to a bracket 2.25 minus 0 and 2.25 minus 4.5. Okay, and then after that we simplify it. So what we do is we times we minus this with this and minus this with this, so we get this one. 2.25 equals to a bracket 2.25 and negative 2.25. yeah, and then after that we will times this together, yeah, and we get 2.25 equals to negative 5.0625a. So what we need to do is we just switch the side. We divide, not switch the side, we divide both side with negative 5.0625. yeah, and so this side goes off and it comes to this side, and we have this thing. And after calculating, we will know a equals to negative 0.4938. yeah, so here's our a, and the result for this for a is this one. yeah, I told you. So we reform the function to here, y equals to negative 0.4938 bracket x minus 0 x and bracket x and minus 4.5 bracket, and keep simplifying it to y equals to negative 0.4938 bracket x squared minus 4.5x, and then after that we times in this thing and this thing, so it will be a negative 0.4938 x squared plus 2.25x. And here is our final function, and after that we go to Desmos, the graphing website, and we graph it, and this is how the graph will be looked like at the end. Okay, so this is just for arc A, and we still have arc B, right? But it's the same thing in arc B. I just don't have enough time to do arc B, but I just explain all the things to here so you can understand. And let's go to phase 2. Okay, in phase 2 I go to take two different things, two different things to come and create our own parabola. Okay, so one of them is the water drinking fountain, another one is the rainbow, and I'm supposed to find the height and the length by myself and insert the image into Desmos like this. So basically I take a picture and then insert it in the Desmos, so it'll be like this, as you see, and I use my formula to find the equation, and here's the working. So I can see the distance of the of the x, how long it shoot and how high it is. And we do the same thing. This is the basic formula we want at the end, but we break it down to be this one. And you can see here m is 1 x-intercept and 3 is 1 x-intercept, and we find the vertex by divide this, add this 2 and divide it by 2, right? So it'll be here, and as we see 1.25 1.5 is also over here, so it's the coordinate of the vertex, and then we add it all in together. We will get this thing. 1.5 equals to a bracket 1.5 minus 0, and then bracket 1.5 minus 3 bracket. After we simplify it, it will become here 1.5 equals to negative 2.258, and then we, as we said, we switch sides and we get this thing as the a, and we put a inside, simplify all the things again, and we get the final formula from over here. And then all we do is we just go to Desmos, we graph it in, and it will look like this. And we just open it and label all the things here, as you can see, right? And here's also the second one of the rainbow one. As I said, I find out the length and the height, and do all the steps again, height and length. So this for rainbow, this thing is for rainbow one, this here's for rainbow. Yeah, I just show you here. Okay, so here is the rainbow, 0 to 5, and the height is 2.25. Yeah, and here's the working. So 0, as you can see, 0 to 5. Yeah, 0 and 5, and the 2.25 is the 2.25. I mean, and the 1.4 is over here, and we find 2.25 by adding 2 together and divided by 2. Okay, so we fit in all the informations and come out, and we go find a. Here's the a. Yeah, here's a, as you can see. When we go divide it all those things and get this thing, it's negative 0.224, and we put a inside and put the what we call the x-intercept inside there, and then we just times it, yeah, and just reverse it, and we get the final formula. Here's the final formula. After I graph it in the Desmos, it looks like this. Yeah, it looks like this. You can see it. And here's the end of the phase 2. Okay, so let's come to result. So in result, as you can see, the arc A, we do the same thing and same other thing that we just talked about, right? And the result is here. I show you for arc A, and here's the arc B that I not show you in the first, but here's the arc B that I just show you. I'm showing you right now. After doing all those things, the result will be here. Very nice parabola. Yeah, it's equal. Yeah. So phase 2, the result. Okay. And yeah, I told you 0 to 3, so it's shooting 3 inches, and the height is 1.5 inches. Yeah, great. And the result I already showed you here. Even for the rainbow, yeah, you see that these are the results that I get. Here's a rainbow. Yay, rainbow again. Okay, so let's come to discussion and conclusion. You're almost there. Don't be too bored. Yeah, we're almost there. So discussion. So as we know, the equation for each parabola should be very specific, and each of them have their own parabola equation. If you change a little bit, think that the parabola wouldn't be accurate as before. I think you should know that. For example, if we change the b or c or a any part of the parabola, the quadratic equation, the equation will be just move away from the place where it should be in it. Could change x-intercept very easily, including the vertex. So basically it means that if you move any number over there, this graph will change for sure. It will change, and it can just like have a very big change, you know. Yeah. Okay, in conclusion, so this big project is basically all about how to find a parabola equation with limited information. What I mean by limited information is two x-intercept and the height, and explains all the details to the people who needs it. For example, people who works for animations, and in this project I chose a rainbow and water fountain to complete the task, and I just need to measure the length, which is the x-intercept, and the height, and we can find out the equation very easily. And here is the standard reflections. Here's the standards for this quarter, and I'm going to explain about these standards and show the examples. That's a lot. Okay, let's go back to, let's finish this faster. Come on. Okay, here. Okay, so SSE2, use the structure of right example. So in the big project, we often switch formulas like this. This standard is about like this, that you identify the expressions and which structure it is, and how do we switch it. Like example, like we just did, using this quadratic formula, we make it factorized to become like this. So the reason we learn this is this is one of the most simple thing in math, in algebra. Oh, spell wrong. Sorry, excuse me. Algebra. Life is all about math, and every day is like missing things. Mathematics, scientists, and engineers all needs like this kind of knowledge of equation to make our life better. If you want to be an engineer, scientist, or mathematicians, you probably should know this. Yeah. Next will be get category of SSE3, and this is separate parts, have A, B, C, and here is the part that where should we factorize a quadratic expression to reveal the zeros of the function it defines. So this standard we use to find the x-intercept. First we have the quadratic expression here. I factorize it to this, as you can see. So when 2 times 5, here 2 times 5, we will get negative 10, yeah, right here. And when negative 5, oh crap, I did something wrong. Not this thing, it should be positive. And when negative 5 plus 2 is equal to negative 3, yeah, it's right. So in here we will get a separate x plus 2 and x minus 5. Agree? Yeah. And now we'll find the x-intercept. After we get to this step, it'll be very easy. Yeah, as you can see, we just take it out and put the other side as 0, and we switch the side, and we find the answer. So here we get negative 2, and here we get 5. So the x-intercept are negative 2 and 5. Okay. So here's the B. Complete the squaring quadratic expression to reveal maximum. Okay. So here is complete the squaring quadratic expressions and find the maximum and minimum. Okay. So here's the quadratic expressions, right? But there's negative, so we just times it all with these things and it switches. See that? And we just switch the side of 6 to here first, so we can complete the square, right? And we must add something on both sides to complete the square. So we get this 5, which is the b, and divided by 2 and to the power of 2, so equals to 25/4, and we add this on both sides here, and it'll be like this. Okay, and next standards. Okay, oh my god, my throat is dry. Okay, never mind, let's start again. So in here, use the properties of exponents to transformation example. Okay, so using the word information, we write the formula. So in here, like they're gonna like give you some information, but it's in word, and you must transfer it into the formula, and you must write it out, the information they have give you. So okay, write this formula. So here is the question. If you deposit $2,500 into the account paying 11% annual interest compounded quarterly, how long until there is 4,500 in the account? Okay, so in this case, PV, which is the past value, is 2,500. You see, yeah. The FV is future value, that amount that we want, yeah, the one. And T is time. We don't know how long the time it is, right? And N is how many times we must do it. Like you see that quarterly means 4, so we just write 4 over there. And the R is the rate, so the rate of change is 11, and put it here. So we have all the information, but T is missing, so we put in the information to the function of this. So it'll be FB equals to PV and bracket 1 plus R over N into the power of T times N. Okay, so after we fit in all the information, it will be like this, but we are not able to find the T by hand, so we just go to decimals and graph it, and as you can see, here is the T, here's the answer, yeah. And next, oh, this is easy, I love this. So APR point 1, perform arithmetic operation on polynomial and build and simplify the quadratic. So it basically, you have two things, like P and Q are polynomials, and P is equals to a quadratic thing, something like this, like x plus x to the power 2 plus 3x minus 5, and Q is x plus 5. And so you must know when P plus Q, P minus Q, P times Q, what it will be. So let's do this. Okay, let me take a break. Wait, give me 5 seconds. 1, 2, 3, 4, 5. Okay, let's start again. So when P plus Q, it will be, we write the formula down, equation down, like x to the power of 2 plus 3x minus 5, and as you can see, 1 plus, right? So we plus here, and then put the equation, another equation over here, so we combine it. After that, we just take this thing out, because we're just gonna plus it, right? Very simple. So here is what we do. Here x over 2, x to the power of 2 still stay the same, and here, as you can see, there's an x, right? We add it together, so it'll be 4x, and there's negative 5 and plus 5, it cancels each other, so there's nothing anymore. So here's the simplified way, yeah. And when P minus Q, we write the formula, we write the equation here again, you see, but this time we put a negative in here, because you want us to find negative, right? So we put a negative here, and then what we do is, as you can see here, there's a negative at front, so what we do is we times in and times in to get rid of this one. Okay, so we'll get x square plus 3x minus 5 minus x and minus 5. And the answer will be x to the power of 2 plus 2x minus 10, because 2x, as you can see, there's nothing similar, so you cannot change. And the 3x you minus with the x, you get 2x, and negative 5, no, minus negative minus 5, you'll be negative 10. Yeah, it's correct. And when p times q, this is gonna be the hard one, but it's pretty easy though. So x squared plus 3x minus 5 times x plus 5. So what we do is we x to the power of 2 times with x, so we get x cubed, right? And x2 plus times 5, we get 5x to the power of 2. And when 3x times x, we'll get 3x to the power of 2, and times with 5, we'll get 15x, and plus when negative 5. Oh my god, this really confusing me, man. I think it is something wrong here. Negative 5 times x, it should be negative, right? It should be negative. Yeah, it should be negative. So we should negative 5x and times 5 and 25, so it'll be negative 25. Oh crap, I should change something. So here will be 3x and 5x and 15x. It should be, oh yeah, here's over here is correct, but I just make a sign wrong there. As you can see, we simplify and add and subtract everything is together, and we get this thing. Yeah, this is the simplest form that we can do. And next standard, REI4. Solve quadratic equation in one variable. So choosing the best way. So in here, we're supposed to choose like the best way to solve the quadratic equation to find the x or something like this. So the possible way there, the possible ways are finding the factors like factoring, or complete the square, or use the quadratic formula. So the first choice, we're gonna use factoring. It's like easiest way, and then complete the square. If you still can't do it, just use the quadratic formula. Okay, so the example one is solve x squared plus x minus 6. And yeah, you can see that and here is the factor that we found, because when negative 2 times 3, we will get negative 6, right? But when 3 minus 2, we'll get 1. Yeah, so it'll be 1x, right? Yeah, right. And after that, we do all the things again. We find the x and find negative 3 and 2. Yeah, and that's the easiest way that we can do it. But if we see these kind of questions that we cannot just factorize it, we just complete the square. So what we do is, you see here, there's a plus 5 and equals 0, right? But what we do is we switch the side of this one, so be like this, right? And then what we want to do is to rid off of this negative sign, because we don't want it. So we divided everything with this thing, and we will get, with that, and we will get this thing over here. And in order to solve this, we must plus something at two sides. So what we do is get the 3 out and make 3 over 2 and to the power of 2, and we'll get 9 over 4. And plus in two sides, we'll get this. We don't want the 5 over here, so what we're gonna do is we're gonna use 4 times 5 and plus on 9, so it'll be 29 over 4. And as we can see, like the thing that we just did, we simplify it and will be this one, bracket x minus 3 over 2 bracket and square equals 29 over 4. And we don't want these things anymore, you know, we don't want it anymore, so just put the square root on both sides. And then after that, so the bracket and the exponent is gone, right? But there's the square root over here. So what we're gonna do is change the side of this thing, come here and times 2 plus or minus 29 over 2. And here's the simplest form we can do. And be careful, when I put plus or minus, it means there's two possible answer. Either you're using plus or minus. Okay, and that's how you get the 2x. Okay, and next is REI 0.7. Solve a simple sequential linear equation. Okay, so this part is where we solve like two equations. That's like we just like put two equations together and solve it. So first equation we get y equals to 2x and y equals to 15 over x. Okay, put it together, you see? Here is together, right? Oh crap, wait. It should be plus 5. What? I have so many mistakes. Sorry about this, but yeah, forgive me. Okay, here. And then what we're gonna do about this is, wait. Oh, we move the x over here. So what we're gonna do is we times both of these with x. We'll get this thing, and 15 will be here alone, right? We'll get this thing, and here's the x outside. We times it inside, we'll get 2x squared plus 5x equals to 15. And here will be 2x2 plus 5x minus 15 equals 0, because we moved the 15 back to here. And then we simplify it. We simplify both of it by dividing get rid of the front thing, front 2, by dividing all of them by 2, and you get a half of it, right? After getting half of it, we're gonna complete the square to solve it. So we move this one we move this thing to here, to another side, and get a 2.5 over 2 and square, to the power of 2. We'll get this and plus it on two side, and then we want to get rid of the 7.5, which is 7.5 times 4 and add it to the 6.25, and it will be this, as you can see here. And at the first, what we do, we simplify it to here, equals 30 over 4. We're going to get rid of the exponent, so we square root it both sides, and we'll get rid of it, and here will be plus or minus square root of 30 over 4. And then we move the 22.5 over 2 to another side, so it will be x equals to, so we can find x plus or minus. There's two answers, remember, don't forget. And next is the FIF 7a, graph linear quadratic function show the intercept maximum minima. Okay, so here is the quadratic function. The idea is here's linear function, very simple graph, yeah. And in this linear graph, we can see the y-intercept is 1. It's the point where it touched the y, where the line, the y, right? And we can see x-intercept is negative 0.5. Just need to label it, yeah. And next is the quadratic parabola. So in quadratic parabola, we have 2x intercept. And here you can see it's negative 1 and 1. And the y-intercept is 2. And it's also the vertex of it. you know, and which is the maximum. Here's the maximum. We say it's a maximum because it's positive. We face it up, right? So we call it maximum. The coordinate is 0 and 2. So here's another kind. Here's where we find minima. Here's like a upside down one, and here we call it the minima. Yeah, here you see the x coordinate. I mean, you add the x-intercept and the coordinate of minima. Yeah, here. And look at this. FIFH. Write a function defined by expression indifferent but equivalent form. Okay. So here, express factor and complete the square quadratic show 0. So use the always complete the square to solve the factoring. Oh my god, complete the square again. So in here we get the formula, I mean we get equation, but we put it to 0, right? And we move on the side and complete the square here. 6, take the 6 and 6 over 2 and to the power of 2 minus is n equals to 9, and we add 9 in both sides and we factorize it. You can see 3 times 3, negative 3 times negative 3 equals 9, and negative 3 minus 3 is negative 6 equals 11. After that we get this, and we put it x to one side, moving negative 3 to another side. So we get x equals to 3 plus or minus the square root of 11. You see, right? Yeah. And use the properties of exponent to interpret expressions for exponent function, for example. So solve by completing the square again. I'm starting getting bored of this. Come on, let's do this fast. Okay, so we do the same thing. Put the 0, right? You see, put 8 into another side, we'll get this thing, and get a 4 out and do this thing again. We'll get equals 4, and then we add it in both sides. We factorize or factorize. Let me fix this. Yeah, what? Factorize. Okay, easy peasy. So factorize it, and we'll get this thing. Negative 2 times negative 2, we get a 4. And negative 2 minus 2 will be negative 4. Yeah, correct. In here we do all the things again. We move the side and we get this thing. Yeah, it's correct. And compare the property different way. Okay, we are finding which function gives the higher income. Okay, so this is a hard one, very hard one. I mean, one of the most, yeah. So we are comparing two quadratic and compare which have higher, larger minima. Okay, so maximum. So here's one of the quadratic function, and here is another quadratic function. So the function one, we try to solve it. So we use this thing. This is the formula to find x-intercept, and you put it inside here. You can see that b, here's what we call b, and 2a, here's the a, negative 5 is the a, so you times negative 5 2 times, right? So it'll be this one, and then the answer will be 38.5. Here is the and here is the what do you call something, and you put it in the y coordinate. Yeah, and then after that you get this. You can see here, right? You put it here, put in the p, and you get this, and this is the this is the y coordinate of the quadratic, so it's the highest point of this thing, and 38.5 is the x coordinate, you can see. So, and for the function b, we can do the same in this equation. So here is the thing, and then we do use this equation, we get 17.65, and we put it into the formula function, yeah, and we get this. And so as you can see, the two coordinates, so self 411.25 is greater than 5924.22, so function A gives a higher income. Do you agree with that? Yeah, it's true, man. Even though you don't agree, but it's true. And here, linear, quadratic, and exponential a model. A local newspaper has projected that its online revenues and growing at the rate model by y equals to 1.5 to the power of x. Y is printing media only increases at a price of y equals to 36x plus 35, at which point in term of x do online revenues surpass that of print revenues. Use decimals. Of course we're gonna use decimals. It's really hard. Yeah, and you see the functions here, you put in decimals and do all the shades and all the editing here. As you can see, here is the formula, here's the equation of the print media, and here is the growing rate of this thing, yeah. And then so we have the answer at the point 15.79. the online revenue will surpass the print revenues. As you can see over here, here is all like the online revenue is like goes higher than the print one. Yeah, you see, we almost there. Oh my god. Okay, in here we're gonna simplify those things, those ugly things. You see, we must evaluate it. So here's 100 to the power of 1 over 2. In here we change the numerator. Your most numerator is on top one. You see the 1 is called numerator. So we change it to the power of 100 and change the denominator, which is the 2 under here, to become the square root of 100, and you become like this. You see, and we solve it. So 100 to the power of 1 is 100, and to the square root of 100 is 10, because 10 times 10 equals 100. Yeah, and here same thing. So as we say, numerator change to be the power and denominator goes to the root, and we get this, and we solve it. Is this thing again. So what we do is 4 times 4, so this is the square root of this one, so it's 4, and 4 to the power of 3, so it'll be 4 times 4 times 4, you'll be 4 times 4 is 16, and 16 times 4 is 64. Yes, correct. And next we simplify this thing. So this thing, we simplify this, we need to add 2 whole number that at the front, which is 2 and 5 together, but be careful, the root 6 stay the same because it's the same thing, we don't want to add it together. And what we get is 7 square root 6. Yeah, and over here we'll have this thing, simplify this thing. So this is kind of different because we don't have a whole number at the front and we cannot add it together. So what we do is we factorize the 12 square root. First we'll make it to be square root 3 times 4 times square root 3, and we can just root 4 very easily and take it out, and it will be this. You see, so you go outside and it'll be a whole number, right? So it's 2 times square root of 3 times square root of 3, and when 3 times root 3 times root 3, you become 3. That's the rule. And 2 times 3 equals to 6, and here's the answer. And finally we reach the last part of the standard, the complex number system. Okay, so all we're gonna talk about is the complex number. The complex number, which some people call it imaginary numbers, is when you have a negative base number in a root and you can't solve it. You use the complex number to help you to solve it. Okay, so whenever there's a negative base in the root, we use a complex number to solve it, and the complex number is I equals to square root to the square root of -1, or I to the power of 2 equals to -1, and it's the same thing. Yeah, so if there is a negative there's a root -4 and we cannot solve it, we put I inside, so it'll be I equals to what you call root -4, and it is also the same if we write as root -1 times root 4, so it's equals to 2I. And next we're gonna do this to find the sum of this goddamn equation. Oh my god. So as here I already did it, so it will be 4 plus 6I here, yeah, and plus 11 minus 2I, it will be equals to B. Yeah, because 4 plus 11, we switch side, right? Or it's not, wait, we switch sides, so it will be negative. It will be negative, and wait. It will be -11 minus 4. Yeah, that's right. It goes to 15. Nope. Should be 7. We put this thing here. It will be oh my god. Oh my god. Wait. Oh my god. I think in the beginning we were right already. I'm just being so stupid. Just wait a second. I'm gonna. Oh my god, there's a bug. Oh my god. Okay. Okay, that's right. That's right. We are right. We are on the right track. I'll get this thing. So the answer will be 15 plus 4I. Yeah, it's correct. And the last but not the least is using it solve the oh my god, damn. Quadratic equation with real coefficient and complex solution. Here's the example of the not a negative discriminant, so we use a real solution. You see here, and there's the one that we put I inside, but I not did it. So yeah, and here's the reference. Here's the website I used for this whole big project. Only Desmos. Yeah, only Desmos. Yeah, I think that's it. Thank you for listening for like around 30 minutes or something. I seriously need to go take some water. Yeah, and that's it. Thank you for listening.